Okay, so last time we left off in section 4.4, and we were talking about how to sketch radicals. There were really two types. An even has a start point and curves one way. An odd has a center point and the root looks something like that. It curves through it, but it goes in both directions. So that was the big difference between an even and an odd. The first thing we always have to do when we sketch is find this point. For an odd root, it would be the center. For an even root, we call it the start. To find it, you take, we already did this part, but you take the radicand and you set it equal to 0 first. Okay, so let's do that again. Added the 2x. And what did we get for x in this case? 3 over 2. Now, to get the y value, we're going to take that x value, we plug it back in, and that gives us the y value of this point. In that case, let's see, this is an odd root, so we're going to be finding a center point. So let's plug 3 halves back in. What's 2 times 3 halves? 3. So we did this yesterday. This is very good. So 3 minus 3 gives me how much? 0. What was the cube root of 0? 0 times 2 plus 1. 1. So my y value is 1. So we're going to graph that point. And that's where we left off. Okay, so let's graph the point 3 halves, comma, 1. Let's see. Okay, so 3 halves, that's 1.5, comma 1. So we are about right there. Okay, now this is an odd root. So odd root. Tell me, for an odd root, does it go in one direction or both? Well, it goes both. So what we want to do now is put that in on the calculator. I might already have it from yesterday. Yep, still have it. So I typed it in. Bless you. I'm going to use the table. If you have numbers in there, you can clear them. If you don't want to clear them, that's fine. You can just type right over them. But I want to pick some numbers that would fit on my graph. My graph goes from -10 to 10. So in your table, pick numbers that will fit on your graph table. Make sure you scan where you're going up. Okay, thank you. So let's pick, I would say maybe 6 or 7 points. Use the wheel thing. The wheel. Did you scan the wheel thing? Yeah. So let's try like, I would say -10. Let's do them all. Negative, I don't know, maybe -7. -4. Let's do 0. And then let's do a couple positives. 2, 5, 7, 10. I just made up some numbers. Okay. Now just graph those points and that's your picture. So -10, let's see, we're at about 6.7. 1, 2, 3, 4, 5, 6.7. -7, we're at just above 6. 6, 7, 1, 2, 3, 4, 5, 6. -4, I'm at about 5.5. 4, 2, 3, 4, 5.5. 0, I'm at just under 4. 1, 2, 3, 4. Okay. So I'm starting to see some of the curve. 2, -1. 5, we're at -2.8. 1, 2, 3, 5. 1, 2, there. 7, I mean, I think I have enough points. I can tell what it's going to look like. 7, we're at about negative 3.5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3.5. And 10, we're at just past negative 4. Okay, that was more than enough points to sketch this. There's your basic sketch. Right, let's graph and see how we did. Based on the number of points we did, I mean, it should be pretty close. Okay, notice in the middle it starts to get a little steep, and when the calculator has to draw something that gets too steep, it doesn't know what to do. It almost looks like it's not connected, but that shouldn't happen. It should look more like what I drew, not where there's a gap in the middle. And that's how you sketch a root. Any question on that? All right, let's try doing an even root. So remember, an even root is only going to go one way. So this time I checked points to the left and to the right of this center point. This was my center. Now I'm only going to check points on one side, either to the left or to the right. Okay. What's the first thing we do with that? We set it equal to what? Set it equal to 0. And when I set that equal to 0, what do I get for x? 4/3. Now, take that number, plug it back in, and tell me what you get for y. What's 3 times 4/3? Four. And then 4 minus 4?
0.
0. And the 4th root of 0 is?
0.
0. 0 times 3?
0.
The y value is basically that number that's on the end. So y equals, you're awesome. Y equals negative 2. Okay, let's graph that. That's going to be my start. Notice I didn't say center. It's not the center, it's the start. Okay. So that's about 1.3, negative 2. 1.3, negative 2. Let's put that in the calculator, and that's going to help us get some points in our table. So to type it in, 3 times, now the 4 here doesn't mean 3 times 4 is 12. That 4 is there because it's going to change into my index in a second. Math, option 5. Now it changed the 4 into an index. So it's 3 times the 4th root of 4 minus 3x minus 2. So you type it in exactly, and it should look exactly the same pretty much. Okay, so now we have a choice. We either have to pick values that are bigger than 4/3, which means it's going to curve to the right, or we need to pick values that are smaller, which means it's going to curve to the left. Well, let's go to our table. And if you pick values on the wrong side, it's going to say error. So let's try a value bigger than 4/3. Someone give me a number that's bigger than 4/3?
13.
Well, still, I want it to fit on my graph, though, in case I have to graph, and I only have up to 10 on my graph paper. Yeah, 1.5 is a little bigger. 4/3 is 1.3. 1.5 is a little bigger. I got an error. So picking numbers bigger than 4/3 was wrong. We need to pick numbers small. So that means this graph is going to curve left. Yeah?
Where is it? How do you get to square root, like on your calculator first?
You press math, and then it's the option 5. Before you pick option 5, you have to put the index you want first. So like if you want to do a cube root, you have to press 3, and then what I just told you, math, option 5. Okay, so now let's pick numbers smaller than 4/3. 1, that's a good number. 0, -4, -8, -10. Good enough. You don't need as many points when it only curves one way. Okay, so we've got 1, 1. We've got 0, 2.2, -4, 4. 4, 1, 2, 3, 4. What else? -8, roughly 5. -8, 1, 2, 3, 4, 5, roughly. And -10, just above 5. Okay. So here's our graph. So something kind of like that. Let's see how we did. Gets a little steep on that right side, so I'm wondering if it's going to have a problem. It did. It wasn't able to really sketch the start point. It wasn't able to do it because it was too steep. Our start point, what was it again? 4/3, -2. Yeah, it couldn't do it. So if you draw it the way the calculator did, that's not right. That's most of it, but it should start down here. And if you zoom in, like if I look at that, it doesn't look like it touches the axis at all in that picture. Watch what happens if I zoom in a little bit. Let's just zoom in right near where it ends. Does it look like it touches the axis now? Yeah, so by zooming in, it's showing it better now, but I still don't think it's going low enough. It should be right here. So it should just keep going, but it's too steep. Yep, just saying. Okay, so that's an example of graphing an even root and an odd root. And now we'll do the last thing for this week.
So anytime I type in like a golden number for the table, it just says error.
When you type in what kind of number?
Any negative number, even if I do like -4 for this one, it says it's an error.
And does your Y1 look exactly like that?
Yep.
Let me see real quick. Yep, looks like you got everything typed in, right? Now if we go to table, -5.
Oh, that's fine.
Yeah.
I never.
Yep, you did everything right. Alright, so last thing. We looked at the transformations, we looked at graphing, now we're going to look at solving an equation. This is an example of the kind of equation that we'll solve. Okay, so the goal when we're solving radical equations is basically to get something like this. We want to get the radical by itself on one side. In this problem that I just made up, the square root of x minus 3 is by itself on one side. If I did this, now it's not. So if you have a problem where you have a square root and there's something on the outside, the first thing you have to do is move that 6 to the other side by subtracting. So we want to get a radical by itself. If there's more than one radical in the problem, like something like that, it doesn't matter which one you get by itself. Just get one of them by itself. I think we're going to focus on problems where you just have to get one square root by itself. Now, we've talked about these before. When you multiply both sides by an equation with a letter, or when you multiply both sides of an equation by something with a letter, you have to make sure that your answers work. So the bottom line is check your solution. We'll try maybe one or two of these, and then that'll be it. Okay, so first thing it says is isolate a radical. Is the radical in this problem already by itself on one side? Oh, great. What do you think?
Could you repeat that?
Is the radical isolated?
Yes.
Yes. It doesn't have like +5 or something like that. It is by itself on the left. What kind of radical or what kind of root is this? Yep.
Cube root.
It's a cube root. So we have to do something on both sides that is the opposite of a cube root. What would cancel out taking a cube root? Yep. Well, we have a cube root. So we have to do something besides a root. To the third power, right? We have to cube each side. Cube and cube. When you cube and cube root, that happens. Now, all you have left is what was underneath the root. X squared minus 2x plus 2 equals x cubed. Now, this is going to have 4 terms. Usually when we have something with 4 terms, the way to try to solve it is factor by grouping. What number do we always try to get it equal to if we want to factor something?
0.
We always want to get it equal to 0. So for me, it's just a habit. I always like the highest degree exponent to be a positive. So I'm going to move everything to the right. You could just move the x cubed to the left, but then it would make it a negative. I don't like doing it when it's a negative. You can, I just don't. So let's move everything to the right. So we're going to minus the x squared. We're going to add 2x. And then we're going to minus the 2. Okay, so factor by grouping says, look at the first 2 terms, see if they have anything in common. Does anybody see what both of those terms have in common that we could factor out? Yep. Yep, x squared. If we factor x squared out of x cubed, what am I left with? Yep, just x. And if you factor x squared out of x squared, what are you left with? Minus 1. The hope is we get minus 1 again. That's how factor by grouping works. So now, look at those 2. I don't see a letter we can factor out of both, but does anybody see a number they both have in common? First, 2. So let's try factoring out a positive 2. What would that leave me with in parentheses? Yep.
X minus 1.
Would leave me with x minus 1. 2x minus 2. Perfect. Now, because we got the same thing here and here, factor that whole thing out. So we're going to factor out the x minus 1. If I factor out x minus 1 from what I have underlined in red, What's left? So this would be factored out. What's left there? X squared. Okay. What if you factor out x minus 1 from there? What's left? Plus 2. So now we're at the last step. We have something times something equals 0. Set each one of those equal to 0 and solve. Okay, how about 1? What would I get if I solved this first one? Yep, x equals 1. Okay, let's go through the second one. I have 2 steps to get x by itself here. Abigail, what would be my first step? To solve this for x. Yep, so move the 2 to the other side by subtracting. Good. So now I have x squared equals negative 2. And how do I get rid of this exponent of 2? I take the square root. But what's about to happen right here? We can't do the square root of a negative. It's not that this number is always going to be negative, it just happened to be negative in this problem. So there's nothing we need to worry about continuing here, because we're not looking at imaginary answers. So the only answer that we got for this problem is x equals 1. So what we have to do is just check it, plug it back in and see if it works. Let me move this so we can see the original problem again. Just move all this up. And let's plug in 1. What's 1 squared? 1. 2 times 1? 2 plus 2. And if you plug 1 in on this side, what do you get? You just get 1. What's 1 minus 2? Negative 1 plus 2. 1. So it's the cube root of 1, which is how much? 1. And I have 1 over here. So I got the same number on both sides. So yeah, it worked fine. So we can say that this is an answer. If it didn't work when I plugged it back in, then I'd cross it out, and I would say this problem doesn't have an answer. No solution. But this one worked. Any question on it? Okay, let's try. Let's try one more of these. I'm going to make one up. So this will be the last one. Alright, so let's say we had the square root of x plus 3. This might come out to no solution because I'm just making it up. Probably will. So the square root of x plus 3 equals x plus 1. Okay. Step 1. Make sure that the radical is by itself. Cameron, is the radical by itself on one side here? Yeah, that's fine. Step 2. Once the radical is by itself, raise each side to the power that will cancel it out. So our index here is a 2, because this is square root. How do you cancel out square rooting? It's the opposite.
Square.
Square, right. You're going to raise each side to the second power. Square and square root cancel. So the left-hand side becomes very simple. X plus 3. The right-hand side now has to be FOILed. You can't just say square the x and square the 1. That's not how that works. That's this. It's x plus 1 times x plus 1. That's x plus 1 squared. All right. Caleb, what's x times x going to be? Alex.
X plus 1 or x times?
X times x.
X squared.
X squared. And how about Grady? What's x times 1?
X.
Yep, I'm just going to put that off to the side. And what's x times 1 again?
X.
Another x. So how many x's do we have?
2x.
2x. And Sam, what's 1 times 1? 1. Okay. What kind of equation is that? What?
Right?
It's a quadratic. What do we usually get a quadratic equal to if we want to solve it? 0. So let's get that equal to 0. I would minus the x. Minus 3. That cancels everything from that side. And now from here, just solve it like you would solve a quadratic. If it's factorable, great. If it's not, we got to use quadratic formula. So x squared minus, actually no, that's going to be plus x minus 2. All right, let's try to factor it if we can. That would be amazing. That I made one up that was factorable. So you would need an x and an x. What would be your signs here? 2 pluses, 2 minuses, or one of each?
One of each.
Yep, you need one of each. And 2 numbers that multiply to give me 2.
1 and 2.
1 and 2. And I would try them 1 and 2. See if that works. X times x is x squared. X times negative 1. X times 2. What's 2x combined with negative x? X. That's exactly what we wanted. 2 times negative 1 is negative 2. I couldn't make one up that factored again if I tried. I don't know how. I got really lucky. So, what do you get if you set this first factor equal to 0? Negative 2. Ryan, what do you get if you set the second factor?
X equals 1.
X equals 1. Check them and make sure they work. They might both work. They might not work. Might be one works and one doesn't. Let's check 1 first. So let's move this so we can see the original problem. Or not. We can just leave it there too. That's okay. So let's plug in 1. 1 plus 3 gives me how much? 4. And what's the square root of 4? 2. And now plug 1 in on this side. 1 plus 1? 2. 2 equals 2. That's fine. Let's try negative 2. What's negative 2 plus 3? 1. What's the square root of 1? 1. Now, plug negative 2 in on the other side. What's negative 2 plus 1? Did that one work? No. It's not that we did anything wrong, it's just that that answer is extraneous. So you have to make sure you cross that one out. If you don't, you'd lose probably a point because you got everything, but you forgot to cross it out. Yep. So that's how you solve radical equations. Any questions on that? Okay. So let me see. Do we have one on the calculator? Yes.
It's not letting me type in what I did.
Is that what you type in? Okay, just type in up there. So not too worried about that one. So let me fix that and put the homework up. We already did 5 and 6. Sketch a complete graph. Let's do number 12. That one's fine. 14. That one's good. Solve. 20 is okay. 21 is okay. And 22, that is okay. I'm going to skip 28. 31. That one's fine. And 35, we're going to skip that one. Okay, so it's 12, 14, 20, 21, 22, and 31. Okay, so for anybody that was not here yesterday, I talked about what we were going to do the second half of today, tomorrow, and Friday. So I want to see where people are at with certain things. Okay, so I have some questions that I took directly from the Algebra 1 midterm, the Algebra 1 final, and then the Algebra 2 midterm and final. So these are all things that you would have had, could have had, should have had, probably didn't have, because of COVID and things getting messed up freshman year. But it would be helpful if I kind of knew what those things that were missing were. So we're going to have the rest of today to work on that. Tomorrow, we're going to do the test. Okay, so we're not going to do the test right now because you might have questions on this after you do it. So tomorrow, we'll do the test. Whatever time you have left tomorrow after the test, you can work more on these questions that I'm going to give you. Friday, you have one hour, because it's a half day, so it's a little shorter. But you're going to have 1 hour, and you can finish up anything you need to, either the test or the questions I'm going to give you right now. Okay. So, yes?
Are the questions going to be due on Friday?
The questions are going to be due by Friday. Yep, but we're only going to work on them in class. We're not going to do the questions for homework. That's the homework for tonight. Depending on how you do on the questions, I'm going to give you extra credit on this week's test. So, like I said, I was going to make it worth 10 points. So if you get 100, you get 10 points. If you get a 50, you still get 5 points. Okay, so probably make it worth 10 points. And it's going to be just on a piece of paper. It's not on Edge Elastic, so you're just going to do it on a piece of paper. That's all. Any questions on that? All right.